In the previous session, we have already completed what? We have completed the intercepts by the circles, power of a point, and length of tangent. This we have already completed today in the morning. So now, in this class, what we will do, we will start with the two left portion, which is equation of various tangents. Mainly we will learn tangents, and then we will go for director circle. Okay, so before starting the class, as I have promised that I have given you one sum as your homework, and that sum I'm going to complete first, and then we will move for the rest portion. If the length of the tangents drawn from the point 1, 2 to the circles this and this, these are the two circles given to you. So let me just draw the circle first. So these are the two circles. One circle is here, the another one is here. Let us say there is a point. There is a point somewhere here, and the point is 1, 2. Now what I'm doing, from this point I am drawing two tangents. One on the first circle, and the second one is in the second circle. So if I draw those two tangents, this is the first tangent, and in the second circle I have drawn this tangent, right? Now they have said that the length are in the ratio 4:3. The length are in the ratio 4:3. So what to do? As we all know how to find out the power of a point, and root of power of point is nothing but the length of the tangent. As we have learned the power of point. Power of point means, if the equation, I'm just revising, if the equation is this is the general equation of the circle, and there is a point, say x1, y1, which is outside the circle. From there, if we draw the tangents, the length of the tangent will be root of S1. This we have learned. What is S1? S1 is the power of the point x1, y1 with respect to the given circle. Now, S1 will be here what? It is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equals. So the length of the tangent will be root over of this power of the point. So from this point 1, 2, if we draw the tangent, this tangent, the length of this tangent will be what? It will be root over of 1 square plus 2 square. I'm putting this point in this equation. So 1 square plus 2 square plus 1 plus 2 minus 4. So that gives us 2 plus 1, 3. So it's coming like 4, 5, 8, 4. So it is basically coming to 2, right? This is the length of the tangent. Let me just name it. It's A, B, and C. So AB is your 2. And what about your AC? Now, the common mistake that students used to do is that they straight away put this point to this equation. That will be absolutely wrong. If you want to find out the length of the tangent, the form should be in this. It should be in the form like x square plus y square plus 2gx plus 2fy plus c equals to 0. That form should be there. In this case, your 3x square and 3y square, 3x square plus 3y square is there. So here you cannot directly put the value to get the power of the point until and unless it is of this form. So what I have to do first is, the given equation, I have to write this thing in this way: x square plus y square minus x over 3 minus y over 3 plus k by 3 equals to 0. So I have divided both sides by 3. Now I can find out what is the length of the tangent by simply putting this 1 and 2 in this expression, right? And after that taking the root sign. So the length of the tangent now it will be 1 square plus 2 square. Okay. So this length is coming to what? 1 plus 4 minus 1 plus k over 3. So that gives us under root 4 plus k over 3. Now by the problem they have said that 2 over root 4 plus k by 3, this is equals to the given ratio 4 over 3, right? So we are having now square both sides, so it gives us 9, 4, 4 plus k over 3. So from here we can find out the value of k. It is coming like 9 minus 16 equals to 4k over 3. So this is coming like minus 7 into 3 over 4 is nothing but k. Therefore, your k is coming to minus 21 over 4. That's it. Is it clear? Hence, option D is correct. Is it clear to all? Is this clear to all?
Yes, sir.
Okay. So
Yes.
it was a pretty simple sum. Why I have chosen this sum? Because sometimes students used to do this mistake. Please do remember this, that whenever you are finding out the length of the tangent, that is, you are finding out the power of the point, the equation of the circle should be always in this form: x square plus y square plus 2gx plus 2fy plus c equals to 0. Please do remember this. Until and unless the form is this, you cannot find out the power of the point, that is S1, hence the length of the tangent, which is root over of S1. Okay, so now let us move for our next portion, which is equation of tangent to a circle. Now you see, one thing we know, that if there is a circle and if there is a line, this line and this circle, it has three kinds of relation. What are they? If this line doesn't touch the circle, this is one condition. Or this line is touching the circle at only one point, this can be another condition. Or this line is touching this circle or intersecting the circle at 2 points. So these are the three conditions that a line and a circle can hold. Now, the line which is not touching the circle, I don't have any relation with that. I don't have any relation with that line which does not touching the circle or intersecting the circle. The line which is touching the circle at only one point is what called your tangent. And the point where it is touching is what called your point of contact. Okay, so when the line is touching the circle at only one point, we call that line a tangent, and the point where it is touching the circle is what called your point of contact. And this line which is intersecting the circle at 2 points is what called your secant. So I'm going to discuss here about the tangent as well as secant. Throughout our circle chapter, we will discuss not only in circle, in all the conic sections, we are interested about these two lines, the tangent and the secant. I'm not at all interested for that line which is not touching or intersecting the circle. Okay, now my question is very simple, that we are having a line y equals to mx plus c. Now my question is, what is the condition? What is the condition what is the condition such that this y equals to mx plus c is a tangent to the circle x square plus y square equals to a square, which is the standard form of any circle. So now, if this line is a tangent to this circle, listen it very carefully. If this line is a tangent to this circle, so let me try to solve these two equations to get the point of intersection, which is nothing but the point of contact. So if I solve these two equations, what we are going to have? Let me expand this. So we are actually getting right. Now the question is, it is a quadratic equation in x. So definitely if I solve this, I am going to get two values of x, let us say x1 and x2. But since y equals to mx plus c is a tangent to this circle, as it is a tangent to this circle, it means it is going to touch the circle at only one point. It is going to touch the circle at only one point. That is, we are not going to get x1 and x2 differently. We are going to have the values of x which is equal because it is touching the curve at only one point. So only one value of x you must get. That is, the roots of this equation must be equal. Are you getting my point? The roots of this equation must be equal, because if the roots are equal, then you are going to find out one value of x. Why? Because the line is touching the circle at only one point. Okay, so when we are going to have only one value of x, actually we are getting two values of x, but they are equal. It is possible only when the discriminant of this quadratic equation is equals to 0. So discriminant means b square minus 4ac. So let me just write it that. Minus 4ac, which is equals to 0. So 4 goes off. Let me open the brackets. So we are getting m square c square minus c square plus s square plus s square m square equals to 0. And this will go off. So we are having actually c square equals to a square into 1 plus m square. And that is the condition. That is because in the beginning of this question, I told you that I want to find out the condition for which the line y equals to mx plus c is a tangent to this circle. And we all know that to find out the equation of the to find out the condition, we need to find out a relation between the constants. Here the constants are m, c and a. So we got a relation which is nothing but c square equals to a square into 1 plus m square. Now a question can come, say, do I have to remember the method of finding out this condition? My answer is yes. You must remember the method, because in some questions we cannot use this formula. We will come across those questions afterward. But remember this, when we are unable to find it, because you look very carefully, we have taken a standard form. I haven't taken the general form of the circle, and from there I haven't got the condition. But how to find out that condition in that case? In that case, you have to follow the method that I have done. what I have done, you will simply assume that y equals to mx plus c will be a tangent to the circle when it is touching the circle at only one point. So for that, while you are solving these two equations, you are going to have both the roots equal. Both the roots equal. So in that case, you will simply put the discriminant equals to 0 to find out the condition. So now we got that for a standard form x square plus y square equals to a square, y equals to mx plus c will be a tangent when c square equals to a square into 1 plus m square. That's it. We have to remember this, as well as we have to remember the method how I got this one. So what will be the equation of the tangent? If c square equals to a square into 1 plus m square, then c can be written as plus minus a root over 1 plus m square. So the equation of the tangent is y equals to mx plus minus a, because here I am putting the value of c, root over of 1 plus m square. That's it. That's it. So this is the equation of the tangent. And the condition that y equals to mx plus c will be a tangent to the circle x square plus y square equals to a square is c square equals to a square into 1 plus m square. That's it. Is it clear to all? Is this clear to all? If you have any question, you can ask me. Let me take one problem. Okay. So now the question is, find the condition for which the line, this one, find the condition for which the line Lx plus my plus n equals to 0 will be a tangent to the circle x square plus y square equals to a square. This is the line and this is the circle. What is the condition for which this line will be a tangent to this? Now, if you want to do it by the normal method, the method that I told you, suppose I have forgotten this condition that c square will be equals to a square into 1 plus m square. Though it is not desirable, but let us say that we have forgotten this formula. So in that case, how to find out that condition? Now you have to follow the same method I have done. So right now I'm not doing that. You can do it by yourself. Here we will directly apply the formula c square. The condition is c square equals to a square into 1 plus m square. That is the condition that we have learned. But when this condition is applied, when we are having the equation of the tangent in this form, be very careful about it. The form of the line was y equals to mx plus c. So in this case, we have been given Lx plus my plus n equals to 0. So if we really want to use this formula, we have to convert this line in terms of y equals to mx plus c. So that's exactly what I'm trying to do. Okay. So now in this case, we can easily see that our m is basically L over m minus, and our c is basically minus n over m. Okay. So what is the condition? The condition will be c square equals to a square into 1 plus m square. That is, c square means minus n over m whole square is equals to a square into 1 plus m square. M square means this square. So what we are getting? N square over m square equals to a square m square plus l square. That's it. So just cancel this one. So we are having n square equals to a square into m square plus l square. See, this is the advantage if we remember the formula. That is the advantage if we remember the formula. Otherwise, what we have to do? We have to do it again. We have to use this method to find out this condition. That's the reason why I told you to remember that as a formula. So let me just revise once more. Y equals to mx plus c will be a tangent. Y equals to mx plus c will be a tangent to the circle x square plus y square equals to a square. The condition is c square will be equals to a square into 1 plus m square. Please do remember this to solve the problem quickly. Okay, let us see this question. A very interesting sum. The question is, find the range of values of the constant c. Find the range of values of constant c such that the solution set of the system x square plus y square less than equals to 25 and 3x plus 4y equals to c, c is a constant, is infinite. What should be the value of c or the values of c such that the solution set of x square plus y square is less than equals to 25 and 3x plus 4y equals to c will have infinite number of solutions? That's the question. Now you have to understand one thing before doing the sum, that what do you mean by? See, if we have been given only x square plus y square is 25, we know what it is. It's a circle whose center is at the origin and radius is 5 units. This we know. So where does this x and y lies? X and y lies on the circumference of this circle. X and y lies on the circumference of this circle. And this is what is called your ring. Ring means the points are always on the circumference of that circle. It's a ring. But the moment you say x square plus y square is less than equals to 25, it means what? We are talking about all the points inside this circle as well as on the circle. Because any point you take inside the circle, it is going to satisfy this inequation. So x square plus y square is less than equals to 25. It means we are talking about all the points inside the circle as well as on the circumference of the circle. And this is what is called your disk. The disk is, what is a disk? Now every point, if you consider a disk, you have seen the CD disk, isn't it so? So in that CD disk, every point inside as well as on the circumference are considered. It is a disk. And when the points are on the circumference of the circle, that's a ring. So here the question is x square plus y square. Let me just erase those. So in this case, we have been said about the disk, that is everywhere inside as well as on the circumference of the circle. I mean, your x and y is lying anywhere in the circle, inside or on the circle. Now we are having a straight line there. Let us say the line is this. Now suppose if the line is this, please tell me, will you ever get any solution? If the line is this, will you ever get any solution?
No, sir.
No.
No, sir.
Okay. Now, let me just do one thing. Let me just take this line at this point. Please tell me, are you going to get infinite solution for this too?
No, sir.
No,
No, sir. We'll
because
get
in this
only
case you are
one
going to have
solution.
only one solution.
One solution.
Okay, but what is the question? We want infinite solution. So it's very clear to us, it is very, very clear to us that this line should definitely be a second to this circle. Because if this line is a second, you see, every point on this line, which are infinite points, are going to satisfy the equation of the disk. Because in the disk, your xy is lying inside the circle or on the circle. So if you want to find out the common points, the common point is going to satisfy this equation as well as the equation of the disk. So one thing is clear to us, that this straight line is neither a tangent nor a line which is not intersecting the line, the circle. It is the line which is basically the second to the circle. That's for sure, to get infinite solutions. Now, what should be the range of C for this? Okay, so this is the equation of the circle, which is x square plus y square equals to 5 square. So the center is where? The center is at origin, and radius is 5 units. Radius is 5 units. Now, the equation of this line is 3x plus 4y minus c equals to 0. So now, from this point, listen it very carefully. If this line is a second to this circle, then if I draw a perpendicular from the center on this line, if I draw a perpendicular from the center to this line, then this distance has to be less than the radius of the circle. Then only you can say that yes, sir, this line is a second to this circle. Tell me yes or no.
Yes,
Yes,
sir.
sir. Yes, sir.
So, what is the perpendicular distance drawn from the origin on this line? It will be 3 into 0 plus 4 into 0 minus c divided by root over of 3 square plus 4 square. This is the perpendicular distance. And this has to be less than the radius of the circle, which is nothing but 5. So we are getting modulus of c over 5 is less than 5. So that implies what? Mod of c is less than 25. So from here what you can say, your c is lying between minus 25 and 25. That's it. Now one question you can ask me, sir, why you have not taken an equal sign over here? No, I am not going to take an equal sign, because the moment this distance becomes the radius, this line then becomes the tangent. And tangent is intersecting the circle at only one point. There we are not going to get infinite solution. That is the reason why I have not given an equal sign over here. Is it clear to all? Have you understood what I want to say?
Yes, sir.
Yes.
Yes.
Can you explain this once more?
Okay, so the range of C here is nothing but from minus 25 to 25. That's it. Okay? Okay, so now let us move for another conception, which is various forms of tangents. See, these three forms we have to remember. All these three forms we have to remember. There is no choice, because in the question, as the question demands, I will use different forms of tangent. But anyways, I'm not going to tell you to memorize blindly. I'm definitely prove all those equation of tangents, then only I will say to memorize. And definitely I'm going to give you some shortcut tricks to remember this equation of tangents. The first one, I think I don't need to prove it because I have already proved this one. This is what is called your slope form of tangent. I have already done this. I have already done this here. You can see this. See, y equals to mx plus minus a root over 1 plus m squared. That exactly, which is known as your slope form of the tangent to the standard circle x square plus y square equals to a square. So this we have to remember, and we have already proved it. Now the second form is what called your Cartesian form of tangent. What is that? Okay, let me just draw a circle first. Now this is a circle and there is a point. The equation of the circle is the standard one, x square plus y square equals to a square. And we are having a point x1, y1 on the circle. Be very careful. Here the x1, y1 is on the circle. And I want to find out the equation of the tangent at this point. I want to find out the equation of the tangent at this point. That's the question. Okay, so how to do that? Well, this is our center, which is 0, 0. And if I join the center with the point of contact, then we all know that this one will be your 90 degrees. This we all know. Okay, in class 10 only you people have all learned this, that whenever the point of contact is joined with the origin, it is always perpendicular. Afterwards, we will learn that this is nothing but the normal of a circle. That we will learn later on, not now. So now we have to find out the equation of this circle. I'm sorry, of this tangent. So what to do? Simple thing. You see, to know the equation of any straight line, as I have mentioned repeatedly, you need two things. One is through which the line is passing. I mean the point through which the line is passing. And number two, what is its slope? That's it. So I know that this tangent is passing through the point x1, y1. This we know. The only thing that we don't know is the slope of this line. So to find out the slope, let me find out the slope of this line. Let me just give a name. What is the slope of AC? 2-point form? It's y1 over x1. Now, if the slope of AC is y1 over x1, then definitely the slope of the tangent is minus x1 over y1. Why? Because this line AC and the tangent, they are perpendicular to each other. Therefore, the product of their slopes will be equals to minus 1. So the slope of the tangent is minus x1 over y1 and the point is x1 comma y1. Therefore, the equation of the tangent will be what? Y minus y1 equals to minus x1 over y1 into x minus x1, point slope form. So it comes to y1 minus y1 square equals to, so from here we are getting xx1 plus y1 equals to x1 square plus y1 square. Now x1, y1 is a point which is lying on the circle. Hence it must satisfy it. That is x1 square plus y1 square will be equals to a square. Therefore, I can replace this by a square. So we are getting the equation of the tangent as a square. That's it. That's exactly what I have written over here. The Cartesian form of the tangent is x1 plus y1 equals to a square. What is x1, y1? x1, y1 is a point. Repeatedly, I am telling you this. x1, y1 is a point. Why you will understand this later on. Why I am telling you that x1, y1 is on the circle. That you will understand afterwards. So x1, y1 is a point on the circle, and at that point only you are going to find out the equation of the tangent, which is nothing but x1 plus y1 equals to a square. That's it. So is it now clear to everyone? Is this clear to everyone?
Yes, sir.
Okay.
Yes, sir.
So two forms we have learned. One is the slope form of the tangent. The another one is the Cartesian form of the tangent. At the same time, I have shown you how to find these equations. Now, the last form is what called your parametric form. We all know, we have already learned this, x square plus y square equals to a square. The parametric form is what? It's any point on the circle. In the parametric form, we write in this way, a cos theta, comma, a sin theta. Right? X equals to a cos theta and y equals to a sin theta is basically the parametric form of a circle. This we have already learned. So instead of saying x1, y1 is any point on the circle, we can say any point on the circle be a cos theta and a sin theta. So in that case, what will be your this equation transformed to? In place of x1, I am simply writing a cos theta, and in place of y1, I am writing a sin theta, which is your a square. So if you cancel a from both sides, we are going to have what? We are going to have a cos theta plus y sin theta equals to a. That's it. And that's exactly what I have written here. This is the parametric form of tangent. Okay? Is it clear to all? Is it clear to all?
Yes, sir.
So these three forms you people have to remember. Slope form of the tangent, Cartesian form of the tangent, as well as the parametric form of the tangent. Now, as I told you in the beginning of starting this slide, that I'm going to tell you a shortcut method. Suppose if I ask you, though we will do this one, let me just do it in another page. Suppose if I give you, say, equation of a circle is the general form. And if I ask you to find out the equation of the tangent at the point x1, y1. x1, y1 is very much on the circle. Be careful. Again, I'm telling you. So find out its equation of its tangent, which is also called your, what we have learned here, Cartesian form of tangent. So in this case, what you will do? We are having a circle. The equation of this circle is this one. And this is a point, let us say x1, comma y1. Now I have to find out the equation of this tangent over here. The center is where? Minus g, comma minus f. Now exactly the same way I taught you right now, you do it and you are going to get. How you will do it? You will simply find out the slope of this line. That is the line joining the point of contact and the center. You will get the slope of this line. So automatically you are going to get the slope of this line. That is the slope of the tangent. So now you know the slope of the tangent and it is passing to the point x1, y1. So you can easily find out the equation of the tangent. And the equation of the tangent will come like this. X1 plus y1 plus g times x plus x1 plus f times y plus y1 plus c equals to 0. That's it. Now you will say, sir, it is very difficult to remember. No, it's not difficult. The method that I'm going to teach you, it will be no more difficult. Remember one thing, not only in circle, but for all the conic sections. Remember in this way. If you really want to find out the Cartesian form of tangent, all you do is for any curve, remember this, you replace x square by xx1. You replace y square by yy1. You replace 2x by x plus x1. You replace 2y by y plus y1. And other thing of that curve will remain same. And that will be the equation of the tangent. Look at carefully what I have done. Here there was x square. So I have replaced that with xx1, y square, yy1. It was 2gx. It means what? G into 2x. So this 2x is written as x plus x1. Similarly, 2fy means f into 2y. This 2y will be written as y plus y1. And don't touch the other thing which is there. That is here, it is c. So your c will be here. That's it. That will be the equation of the tangent. You see the previous one? You see the previous one? What was the equation? Now you will understand. What was the equation? Your circle is x square plus y square is a square. So what will be the equation of the tangent? At the point x1, y1, it will be xx1 plus yy1. There is no 2x, there is no 2y. And don't change any other constant. So that will be the equation of the tangent. That's it. Okay. Now, if I give you, let me just go little out of the track, and let me ask you, let me take an equation of a, say, parabola. Let me take. Suppose we have been given y square equals to 4x. Now you will listen, you will learn this immediately. Now if I ask you, what is the equation of the tangent at the point x1, y1? You can easily give me the answer. No need to remember. This y square will be replaced by yy1. And there is 4ax. 4ax means it's 2a into 2x. This 2x will be replaced by x plus x1. So it will be x plus x1. That's it. That is the equation of the tangent to the parabola y square equals to 4ax. Any curve you take, any curve. Suppose if I take, let me take equation of a circle like this. X square plus y square minus x minus say 3y, let us say minus 5 equals to 0. Let me take this. And if I ask you what is the equation of the tangent at the point x1, y1, listen it very carefully. How you can do it instantly. Here it is x square. So I will write xx1. Then it is y square. So I will write yy1. Then we are having minus x. But I need, when there is 2x, you have to replace by x plus x1. So x will be replaced by x plus x1 over 2. Here there is minus 3 and y is there. So y will be replaced by y plus y1 by 2. Are you getting my point?
Yes,
Are you
sir.
all
Yes,
there?
sir.
Yes, sir.
And
Yes, sir.
don't touch the other constant. That's it. That's the equation of the tangent. Instantly you can find out. Okay, so now we have learned the equation of the tangents. At the same time we have learned how to find out the Cartesian form of a tangent in shortcut way. Okay, so let's take some problem right now, so we will be comfortable with that. Okay, let us see this question. Find the equation of the tangent to the circle x square plus y square. X square, the first one I'm doing, for the circle x square plus y square equals to 4. And the point is root 3 plus 1. So how to find out this? Now we can easily see that root 3 comma 1 is lying very much on the circle, isn't it so? If you put root 3 and 1 in this equation, it is going to satisfy. So this point is very much on the circle. This point is very much on the circle. It is on the circle. So what will be the equation of the tangent? Just now we have learned. It is what? X1 plus y1 equals to 4. So in place of x1, I will write root 3x. In place of y1, I will write 1. So it will give you y equals to 4. That's it. That's the equation of the tangent. How we know? Because we know that this point is lying on the circle. That is why we have used this form, because this form will be applied only when your x1, y1 is on the circle. Again, I am telling you, on the circle. If this point is somewhere here, this formula will not be applied. Until and unless your x1, y1 is on the circle, you cannot use this form. Be very, very careful. Okay, what about question number 2? Find out the equation of the circle to this circle x square plus y square equals to 4 from the point 1, 1. Now 1, 1, if I put in this minus 4, let me say this is my s, and if we find out the power of the point, what we are getting? What is our
Sir, it will
s1?
be inside the circle.
It's 1 plus 1 minus 4. That gives us minus 2, which is less than 0. Less than 0 means the point is somewhere inside the circle. And if the point is inside the circle, you won't be able to draw any tangent. Hello? If the point is inside the circle, can you draw a tangent? Tell me.
No,
No,
sir.
sir.
No.
No,
So
sir.
for the second one, no tangent possible. No tangent possible. Now let us see the point 2, 3. What is the power of the point? It's 2 square plus 3 square minus 4. So the power of the point is 9, which is greater than 0. So I'm sure that this point 2, 3 is lying somewhere outside the circle. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yes. So the point is somewhere here. This point is 2, 3. Now I want to find out the equation of the tangent drawn from this point. Now listen it carefully. Can you use that form? X1 plus y1 equals to 4. Can I use this form to find out this equation?
No,
No,
sir.
sir.
No. No. Why no? Because this point 2, 3 is not on the circle. It is somewhere outside the circle. So we cannot use this form. So now my question is, how to find out this equation? How to find out this equation? You see, the center of this circle is 0, 0. The center of this circle is 0, 0. And this line is passing through the point 2, 3. So how to find out this equation? How to find out this equation? Let us say the equation of the straight line be y equals to mx plus c. Let us say the equation is y equals to mx plus c. Okay. So from the center, if I draw a perpendicular or I join the point of contact, both are same, then this one will be perpendicular to this line. And this length will be nothing but the radius. And radius in this case is 2. Radius in this case is 2. So what I will try to do here, I will simply put, in this equation, I will simply put this is 0. This is the equation of the line. Now let me draw a perpendicular from the origin. So what will be the perpendicular distance? The perpendicular distance will be this is nothing but 2. So you are basically getting C equals to, you are basically getting modulus of C divided by root over of 1 plus m square is 2. So we can say it is C square is nothing but 4 times 1 plus m square. That's okay. Now how to find out the value of m and C? You see, this line is passing to the point 2, 3, hence it must satisfy this. This line is passing, the equation of this line, we have assumed this thing as y equals to mx plus c. As it is passing to the point 2, 3, hence it must satisfy this. So what I'm saying is, it's 3 equals to 2m plus c. So what is your c? C is nothing but 3 minus 2m. So let me just replace this. 3 minus 2m whole square is 4 into 1 plus m square. So from here we can get 9 minus, which is equals to 4 plus 4m square. Is it clear? 4 plus 4m square. Now this 4m
Yes,
square
sir.
and 4m square will go off. So we are left with what? 9 minus, let me do it in the next, or okay, let me do it in the next page. So 9 minus 12m, 9 minus 12m, 9 minus 12m is equals to, 9 minus 12m equals to 4. Right? So 12m is coming to what? 9 minus 4, which is 5. So m is coming to what? 5 over 12. Am I correct or not? Have I written it correctly or not? Please tell me. Is it
Sir,
correct?
one more slope should come, na, sir?
Very good. That's exactly what I was expecting from you people. Because it is an equation involving a quadratic in m. Quadratic in m. And we got only one value of m. How it is possible? It's not possible. So I must get another value. And what is that value? As I told you, as I repeatedly
Sir,
told you, in
infinity.
straight line, your aim will be infinity.
Infinity.
Another value aim will be infinity. So one value is 5 over 12, another value is infinity. Now, if aim is infinity, that means what? The line is perpendicular on the x-axis. That is, it is parallel to the y-axis. And if it is parallel to the y-axis, then the equation of this line will be x equals to constant. And we know that the tangent is passing through the point 2, 3. X is constant. So one equation of the tangent is x equals to 2. Are you getting my point or not? If
Yes,
aim
sir.
is infinity, it means what? It is perpendicular on the x-axis, means it is parallel to the y-axis. And as it is parallel to the y-axis, the equation of that line will become x equals to constant. The tangent is passing through the point 2, 3. The tangent is passing through the point 2, 3. Therefore, the equation of this line will be definitely x equals to 2. And what about the other one? We got m as 5 over 12. And we know that c is 3 minus 2m. So what is c? So it's coming like 13 over 6. Therefore, the other equation will become y equals to mx plus c. That's it. This is one equation and another equation is x equals to 2. Because we can easily see one thing, that from a point, we can easily see from the diagram itself why the equation of two tangents are coming. Because from this point, we can draw two tangents, isn't it so? From any point outside the circle, we can draw two tangents. That is why we are getting two equations of the tangents. One is this, and another one is x equals to 2. Is it clear to all? Is this clear to all?
Yes, sir.
Okay, great. So let me take the next problem. See this question? This came in JMen 2019. What is the question? If a tangent to the circle, side by side, you must try this sum by your own right now. The question is, there is a circle. If the tangent to the circle x square plus y square, the equation of this circle is x square plus y square is your 1. So this is the tangent. This is the tangent. This is the tangent actually. And it is intersecting. And if we draw a tangent over here, it is intersecting the coordinate axis at two distinct points P and Q. Is it clear? The circle is x square plus y square equals to 1. That is, its center is at the origin and radius is 1 unit. Now this tangent is intersecting the coordinate axis at P and Q. We have to find out the locus of its midpoint. Now see, there are several tangents which can be drawn. Which are touching this circle and intersecting x and y at different places. Okay, I can draw a tangent over here. So what I want to do, I want to find out the locus of all those tangents, which is the midpoint of P and Q. Is it clear? So how to do that? Let us say h comma k be any point on the locus. And let us say this point of contact where this tangent is touching the circle, let us say this point be x1 comma y1. Then what is the equation of PQ? What will be the equation of the PQ? That is the equation of the tangent will be what? Tell me. Xx1 plus yy1 equals to 1. Am I correct or not? Please tell me.
Yes, sir.
Sure.
Okay, so this is the equation of the tangent. Now, where it is intersecting the x-axis, put y equals to 0. So we are getting, it is intersecting the x-axis at 1 by x1 comma 0. And it is intersecting the y-axis, put x equals to 0. So we are getting 0 comma 1 over y1. Therefore, the coordinate of P is 1 over x1 comma 0 and coordinate of Q is 0 comma 1 over y1. Now, I want to find out the locus of their middle point, HK. That is, what is H? It is 1 over x1 plus 0 divided by 2, which states H is 1 over 2x1. Similarly, what is K? K is 0 plus 1 over y1 by 2. So that gives us K is 1 over 2y1. Okay. Now, what is x1? x1 is 1 over 2h. What is y1? It's 1 over 2k. Now, you have to find out the locus. Means I have to find out a condition which will involve h, k and constants. We can easily see that x1 comma y1 is a point which is lying on the circle. Hence, it must satisfy this equation. That is, x1 square plus y1 square must be equals to 1. In place of x1 now, I am putting 1 over 2h. So that gives us what? 1 over 4h square. 1 over 4k square, which is equals to 1. Now, this is the equation of the locus. What is the equation of the locus? This one. So, if we simplify, what we are going to have? So, x square plus y square is 4x square y square. So, from here we are getting x square plus y square minus 4x square y square is 0. Hence, option C is correct. Pretty simple sum. As I told you, if you are neglecting this coded geometry, you are missing a lot of marks. You will definitely miss a lot of marks in in this competitive examinations. So that is why I told you, please do the sum properly. Try to remember the shortcut thing that I am telling you and the tips and tricks I am giving you in between. And definitely you have to remember the formula. That's the only criteria to score good marks in coordinate geometry. Sure. So let us move for the next problem. See this question. In this question, they have said that there is a circle C of radius 5 which lies below the x-axis. So let me just draw that diagram first. So there is a circle C which lies below the x-axis. So let us say the circle is this. And then what they have said, the line L1, 4x plus 3y plus 2 equals to 0, this passes through the center P of the circle C. So this circle is C and its center is at P. Okay. Now the line 4x plus 3y plus 2 equals to 0 is passing through the center of this circle. So the line will be something like this, which is passing through the center of this circle. Okay. And L2 is a line which is intersected by L1 at the point Q, and Q is the point on the circle. Q is the point on the circle. That is, this is that line, and the point of intersection of L1 and L2 is Q. Is it clear or not? Now we can all see that L1 and L2, they are perpendicular to each other. Okay. So now we have to find out the distance of point P from the line. A separate line is given. The equation of this line is 5x minus 12y plus 51 equals to 0. So now we have to find out the perpendicular distance from the point P on this straight line. This distance we have to find out. That's the question. So this distance can be easily found if you know the center of this circle. Okay. So now how to find out the center of the circle? To get the coordinate of Q, let me solve these two equations. So the two equations are this one and L2 is this one. Okay. So now let me solve it very quickly. And the second one is coming to so if we subtract, we are going to have. So we are getting y as minus 2. Okay, so y as minus 2. Now if I put it in the first equation, we are going to have, so x is coming to 1. Okay, therefore the coordinate of q is nothing but 1 comma minus 2. Is it clear? Now what is the slope of, now my main task is to find out the center of this circle. Let the center of the circle be alpha comma beta. Okay, so now what is the slope of, L1 equals to 0? So from here we can write, so y is coming to, so what is the slope of this line tan theta? It's minus 4 over 3. So if I draw a right angle, this is going to come 5. Therefore my sine theta will be 4 over 5 and cos theta will be minus 3 over 5, right? Now why I am finding out this? Because I want to find out the point P. We know the coordinate of Q and we know that this PQ distance is 5. So if I use the parametric form, we can easily get the coordinate of P. Okay, so let me just apply the parametric form here. It's alpha minus 1 over cos theta equals to beta plus 2 by sine theta, which is your 4 over 5. This is equals to your r, which is nothing but your 5. Okay, rather it should be plus minus 5. This I have already explained in straight line chapter, why I am giving plus minus sign there. So your alpha minus 1 is coming to, and beta plus 2 is coming to, clear? So alpha minus 1 is minus plus 3 and your beta plus 2 is plus minus 4. So we are having alpha as minus 3 plus 1 or alpha as plus 3 plus 1, right? So that is minus 2 and this is 4. And what about your beta? Beta is coming to plus minus 4, just 1 minute, plus minus 4 minus 2. So we are having either 2 or minus 6. Okay, but since they have said that the circle C is lying below the x-axis, therefore your beta has to be negative. Your beta has to be negative. The ordinate of the center will be negative. Therefore the center will be 4 comma minus 6. That is the center. Is it clear? Now you got the point. Now you know the center P. Now if you know the center, what will be the perpendicular distance from point P on this line? I'm using the perpendicular distance formula. So we are having divided by root over of 5 square plus 12 square. Okay, so we are basically getting what? 2072 plus 51 divided by 13. So it is coming like 92 plus 51, 13. So that gives us 143 over 13. So that gives us 11 only. Is it clear? Therefore, the perpendicular distance of the point P, which is the center of the circle, from the line 5x minus 12y plus 51 is nothing but 11. Is it clear to all? Is this clear to everyone? Okay. Okay. So let us move for the next problem. What is the question? L1 is given, L2 is given. The circle C1, which is of radius 3, touches L1 and L2 and has its center in the first quadrant. Be careful. The center is in the first quadrant. What do you mean by that? The center is in the first quadrant. It means that your alpha beta, if alpha beta is the coordinate of the center, both alpha and beta are greater than 0. Okay, so now the circle C2 is concentric with C1 and cuts of intercepts of length 8 on the lines. Find the equation of C2. Okay, take it. Chalo. Let me just draw this first. Okay, there is one circle. The circle is there. What happened to this circle? Now, in this case, there are L1 and L2 touches L1 and L2. So there are two lines, L1 and L2. This is L1 and let us say this is my L2. Okay. So this is L1, this is L2. And what happened? And the center is at alpha comma beta, which is in the first quadrant. The circle C2 is concentric with C1. This is my C1. There is another circle which is concentric to this. Okay, concentric to this. Concentric means it is having
Same center.
same center.
Same center.
Only the radius will differ. That's it. Yes. Now what happened? Just 1 second. Let me just extend this. Okay. Then what happened? What they have said? The circle C2 is concentric with C1 and cuts of intercepts of length 8 on the lines. Okay. So this C2 is basically intersecting this length. This length is nothing but 8. This length is 8. Both this is 8. This is also 8. This is 8. This is also 8. Okay. So now what happened? Find the equation of C2. I have to find out this equation C2. See, one thing for sure. To find out the equation of C2, every time for finding out any equation of a circle, we need two things. One is the center, another one is the radius. That's it. That's it. C1 has its radius 3. So what I will do, how to find out its center? All I will do is I will simply join this point with the center. And what I will do, I will simply again join this with this point. Now observe carefully this, let me just give a name, A, B, this is C. Now observe carefully, your AB is basically the radius of C2. Now the question is how to find out C2? I mean, how to find out AB? Simple thing. This length, AC is 3. It is given. And how many of you can see that the length of BC will be 4? Am I correct or not? The length of BC will be 4. How many of you can see that? The length of BC is 4. Am I correct or not?
Yes, sir.
Okay. If it
Yes,
is
sir.
4, this is 90 degree because we have joined the point of contact with the center. So by using Pythagoras theorem, what we can say, 3 square plus 4 square is nothing but AB square. So AB square gives us 25, implies AB is 5. So immediately we got the radius of C2. We got radius of C2, which is nothing but 5. Now the only thing that is left with us, you have to find out this alpha and beta. The only thing is that you have to find out alpha and beta. How to find out this alpha and beta? We know the equation of L1. 5x plus
5x
12y
plus
minus
12.
10 equals to 0. And what is the center? Center is alpha comma beta. Now what is the perpendicular distance? That is, what is AC 5 alpha
Root over of
plus
5
12
square.
beta minus 10 divided by root over of 5 square plus 12 square. This is the radius. Again at the same time, if we draw a perpendicular from A on this line, this is also the radius of the same circle. So what will be the radius then in that case? 5 alpha minus 12 beta minus 40 divided by root over of 5 square plus 12 square. And these two are equal. These two are equal. So from here we are getting, this goes off. So we are having, actually I am writing it here. So we are having modulus of 5 alpha plus 12 beta minus 10, which is equals to plus minus 5 alpha minus 12 beta minus 40. So let me take the plus sign. 5 alpha plus 12 beta minus 10 equals to 5 alpha minus 12 beta minus 40. So from here your alpha alpha goes off. So we are having 24 beta equals to minus 30 and beta is coming to minus 30 over 24. Okay. So can we take the value of this beta? Can we take the value of this beta? No. Why? Because I have already said that alpha beta are greater than 0. Your beta cannot be negative. So plus sign is not accepted. So I have to take the minus sign. So if I open the bracket, what you are going to have? So now 12 beta goes off. So we are having here 10 alpha is 50. So what is alpha? Alpha is 5. Hello? Yes or no?
Yes, sir.
Yes.
Yes, sir.
So we got alpha as 5. Now what about beta? How to find out beta now? How to find out beta now? The perpendicular distance 5 alpha plus 12 beta minus 10 divided by 13 is basically equals to 3. So if alpha is 5, what you are getting? 25 minus 10, that is 15, whole by 13 is plus minus 3. So from here we are getting 12 beta plus 15 is plus minus 39. So 12 beta is plus minus 39 minus 15. So 12 beta is basically what? 39 minus 15, or it will be minus 39 minus 15. This value is rejected because from here we are going to get the value of beta as negative, which is not accepted. So we got 12 beta is nothing but 39 minus 15, that is 24. So beta is nothing but 2. So what is alpha? Alpha is 5 and beta is 2. Hello? Yes or no?
Yes, sir.
Yes,
Sir.
Have you understood
Yes,
why
sir.
I have rejected the second value? Because your beta is greater than 0. It cannot be less than 0. That's why I have rejected the second part. So now you know the center. You know the center. At the same time, you know the radius. What is the radius? Radius is 5. So what will be the equation? X minus 5 whole square plus y minus 2 whole square is nothing but your 5 square. That's it. That's your answer. So what is the answer? Let me just check it. Let us verify this. The answer is, yeah, I've opened that one. Okay, no problem. If you open, you are going to get the same answer. Let us check. X square minus 10x plus 25 plus y square minus 4y plus 4 is 25. So 25 goes off. So we are left with x square plus y square minus 10x minus 4y plus 4 equals to 0. That's it. So can you observe one thing? What I am doing? I'm trying to find out the center. I'm trying to find out the radius. Everything you know in circle. As same case in your straight line. If you know the slope And if you know the point through which it is passing, you know everything about the straight line. In circle also, always try to find out its center and radius. Center, radius. That's it. Your focus should be on that. And whenever tangent question is given, always try to join the point of contact from the origin, such that this line will be perpendicular to the tangent, and then try to manipulate and get the answer, as I am doing in all these sums. Okay, let us move for the next problem. So in this question, they have said that the center of the circle C is a circle whose center is at alpha and beta, and whose radius is less than 8. And let these two lines are the tangents to the given circle C, and the line 4x plus 3y equals to 1 is a normal to C. Okay, so let me just draw the diagram first, and then I will explain the question. Coordinate axis. So this is the circle, and we are having two tangents. One is 3x plus 4y is 24, and the other tangent is, let us say, this one. Okay, the equation of this line is 3x minus 4y is 32, and the equation of this tangent is 3x plus 4y equals to 24. Okay, now we can see that they have already said that 4x plus 3y equals to 1 is normal to this circle C. Normal to a circle which is actually perpendicular on the tangent at the point of contact always passes through the center of the circle. Therefore, the normal here is this line, which is actually perpendicular to this tangent. Am I correct? And the equation of this normal is 4x plus 3y equals to 1. And we can easily see that this will be the normal to this point of contact other than this point of contact. Why? Because this line and this line, they are perpendicular to each other. Getting my point? Normal is always perpendicular to the tangent at the point of contact, right? So this point is, let us say, the center B, P. Okay, so now we have to find out the coordinates of the center is alpha and beta, and the radius of this circle is r. Now we have to find out what is the value of alpha minus beta plus r. So for that, we have to find out what is the value of alpha beta. At the same time, we have to find out what is the radius of this circle. So what to do? How to approach this sum? Very simple. The same funda I am using. From the center, you join the point of contact of the first line, and this is the point of contact from the center, the point of contact on this line. Let me just give a name of this. Let us say this is A, this is B. So PB is perpendicular on this line, and PA is perpendicular on this line, and both of them are equals to its radius of the circle C. Okay, so what is the perpendicular distance PA? It is 3 alpha plus 4 beta minus 24 divided by root over 3 square plus 4 square. And what is the perpendicular distance of P on the line 3x minus 4y equals to 32? It will be 3 alpha minus 4 beta minus 32 divided by root over of 3 square plus 4 square, right? And these two are nothing but the radius of the same circle, hence they are equal. So now let me cancel this. So we can write 3 alpha plus 4 beta minus 24 is plus minus 3 alpha minus 4 beta minus 32. Okay, at the same time, remember this alpha beta, which is actually the center of the circle, lies on the normal, which is 4x plus 3y equals to 1. Hence, it must satisfy that. Let me write it here. So 4 alpha plus 3 beta is basically 1. Okay. Now, in this equation, if we take the plus sign, we are going to have 3 alpha plus 4 beta minus 24 is, and if we take the minus sign, we are getting right. So from the first one, we are having this goes off. So it is 8 beta equals to minus 32 plus 24. So that gives us minus 8. So from here, we are getting beta as minus 1. Okay. And from the second one, we are getting 4 beta goes off. So it's 6 alpha is 24 plus 32. So that gives us 56. So alpha is coming to 56 over 6. That gives you 28 over 3, right? Now, if beta is minus 1, and if we put it here, 4 alpha plus 3 beta is 1. So we are having the value of alpha. In this case, it will be alpha is coming to 1. And if I put alpha equals to 28 over 3 in this equation, we are going to have so your 3 beta is coming to 1 minus, it's coming like divided by 3. So it's 3 minus 112 divided by 3. That gives us 109 divided by 3. Correct? Therefore, your beta is coming to minus 109 over 9. Okay? So, your center is either 1 comma minus 1 or the center is 28 over 3 minus 109 over 9. Is it clear? Let me consider your alpha and beta to be 1 and minus 1. Therefore, what will be its radius? The radius is the perpendicular distance from the origin on the tangents. So, if I consider this PA, PA is the radius, or you can consider PB also, doesn't matter. You will get the same answer. So, if I consider PA, so the perpendicular distance will be what? 3 alpha plus 4 beta minus 24 divided by root over of 25. Okay. So now if I put alpha beta as 1 and minus 1, we are going to have. So in this case, we are getting minus 25 over 5. That is 5. And we can easily see that the condition which is given to us that your R is less than 8 is satisfied by this value of R. I'm not finding out the value of R for the second coordinate because definitely it will be more than 8. You can do this calculation, no problem. But since I got my radius which is less than 8 and it is a single option correct question, so definitely this part which is coming here will definitely not be less than 8. Otherwise, we would have got 2 answers. Are you getting my point? So I'm not checking with this. You can check this thing with at home. You will definitely get the radius of this circle more than 8. So this value is rejected. So we got your alpha as 1, beta as minus 1, and your radius is 5. Therefore, the value alpha minus beta plus r will give us 1 minus 1 plus 5. That gives us 7. Is it clear? Hence, option A is correct. Have you got it? Is it clear to all? Okay, let me reveal the answer. Yes, it's A. Okay, so now let's move for the next part. This is various form of tangents. We have already done various form of tangents in case of the standard circle. x square plus y square equals to a square. Now suppose if standard circle is not given to us, but we have been given the general form of the circle. In that case, what will be the equation of the tangents? Now again, I'm telling you, I don't want to create unnecessary burden of remembering all those formulas. If you see any standard book, they have already given you a formula for this general equation of the circle, but I will suggest you not to remember that, because so much of things you cannot remember. So to find out the slope form of the tangent, always use the conception that the perpendicular distance drawn from the center on a tangent is always equals to its radius. Simply use this conception to get the slope form of tangent. I will come with a question. I will take an example. Don't worry about it. But only remember that whenever it's a slope form of tangent and a general equation of the circle is given to us, even in the standard form, we will always use the conception that the perpendicular drawn from the center on the tangent is always equals to its radius. Only by using this conception you can find out the slope form of the tangent, right? Cartesian form of the tangent, I have already explained to you that if the point x1, y1 is on the circle, again on the circle, then the equation of the tangent will be xx1 plus yy1 plus this thing plus c equals to 0. How I told you, you will simply replace x square by xx1, y square by yy1, 2x by x plus x1, 2y by y plus y1 without changing any other constant term which is there in the equation of the curve. Is it clear? So in that way, you are going to have the Cartesian form of the tangents. So again, in this case also, there is no need to memorize anything. Only remember the working rule, how to find out the tangent. One thing you must remember, that for Cartesian form of the tangents, the point must lie on the circle. Otherwise, you cannot use this formula. Now, the last part is what called your parametric form of the tangent. We know the parametric form of any standard form of a circle, as well as we know the parametric form of general equation of a circle. Can you remember that? It's x plus g whole square. I can convert this general form of the equation in this way. Y plus f whole square is equals to root over of g square plus f square minus c whole square, which is actually your r square. So in that case, we will write the parametric form as minus g plus r cos theta and minus f plus r sin theta. This I have already explained in the previous lecture. Okay, so I'm not going to explain this anymore. Now, the moment you have x1 and y1, there is no problem of finding out the parametric form of the tangent simply by replacing this x1 and y1 in this equation. Again, x1, y1 is which point? It is the point on the circle. So you simply replace x1, y1 in this equation, in the Cartesian form of the tangent, to get the form of the tangent which is in the parametric. Is it clear to all? So this form of tangents to the general circle, you have to remember this procedure. Don't try to memorize the formula. Okay? Let us take a problem on this. Let us see this. Find the equation of the tangent to the circle. Just 1 minute. Yeah. So find the equation of the tangent to the circle. X square, what is given? The equation of the circle is this. Right? And it is passing through the point 8, 1. Which one is passing? The tangent is passing. Now my first question is this point on the circle? If it is on the circle, it will take few seconds to find out the equation of the tangent. But first of all, we have to check whether this point is on the circle or outside the circle or inside the circle. So for that, we have to find out the power of this point with respect to this circle. So what will be the power of that point? It's 8 square plus 1 square minus 16 minus 4 minus 20. So we are getting 65 minus 40. So 25 greater than 0. It means since the power of the point is greater than 0, it means the point is outside the circle. The point is outside the circle. Hence, we cannot use our Cartesian form. Okay, in Cartesian form, what was the criteria? The point has to be on the circle, but it is not on the circle. Okay, so this is the tangent. So we have to find out the equation of this tangent, and they have said that this tangent is passing to the point 8, 1. Okay, what is the center of this circle? The center of the circle will be 1, 2. And what is its radius? Its radius is root over 1 square plus 2 square plus 20. That gives us root 25, which gives us 5. Is it clear? Now, let us assume that the equation of the tangent is y equals to mx plus c. As the line is passing to the point 8, 1, hence it must satisfy this equation. Therefore, 1 is equals to 8m plus c, or from here you can write c is nothing but 1 minus 8m. Is it clear? So, c is nothing but 1 minus 8m. Keep it in your hand. Now, what I will do, as I told you, I will use that conception of drawing a perpendicular from the center on the tangent, which will be nothing but the radius of that circle. Okay? So let me just draw a perpendicular from the center on the tangent, which is nothing but your radius, which is equals to 5. But what is the perpendicular distance? The equation of the tangent, we have assumed this one. So the equation, the distance of the line from the center on this line will be m minus 2 plus c divided by root over of m square plus 1. Okay, so this is the perpendicular length, and which is nothing but your radius 5. So from here we are getting m minus 2, and let me just replace this c by 1 minus 8m. So we are actually having minus 1 minus 7m by root m square plus 1, which is equals to 5. So let me square both sides. We are having let us open the brackets. So what we are having, I'm writing it here. So what we are having, 49m square minus 25m square, that is 24m square, plus 14m minus 24 equals to 0. So let me divide by 2. So we are having right. So 12 into 12 is 144, 16 into 7, 16 into 9, I'm sorry. So it's 12m square plus 16m minus 9m minus 12 equals to 0. 3m plus 4 minus 3. So we are having 3m plus 4 and 4m minus 3, correct? So the value of m is coming to minus 4 over 3 and 3 over 4. So when m is minus 4 over 3, from this equation we are going to have the value of c as 1 minus 8 times minus 4 over 3. So that gives us 1 plus 35 over 3, correct? And when m is 3 by 4, then the value of c will be 1 minus, so it's coming like minus 5. Is it clear? Therefore, the equation of the tangents will be y equals to mx plus c, and the other one will be y equals to mx plus c. Is it clear? Hence, the equation of the tangents are this or, okay. So we can write this thing as 3x minus 4y equals to 20. So these are the two equations of the tangents to this circle from the point 8, 1. Now it's very easy to understand that from any point outside the circle, you are going to have two tangents. Yes or no? That is why we are getting the equation of two tangents here. Is it clear to all? Absolutely. Now you have understood when the point is not on the circle, we have to follow this method to find out the equation of the tangent. But if the point is on the circle, then there is no problem of finding out the equation of the tangent to a circle because we know the shortcut method of finding out its equation. Is it clear to all? Okay, let's move for the next problem. Let's see this question. So there are 3 points P, Q and R which lie on the circle. Let me draw the diagram first. This is a circle and the points are P, Q and R. So, and PR is the diameter. So let me write this point is my P. This is R, which is alpha comma 4, and this is Q, which is 9 comma 10, right? Now PR is the diameter. PR is the diameter. This is the diameter. The tangents to C at the point Q and R. At the point Q and R, they intersect at the point S. So if I draw two tangents at Q and at R, they are going to intersect at the point which is your S. Is it clear? This point is S. Now they have said that this point S lies on the line 2x minus ky is 1. What has been said? That this point S lies on this line. So you have to find out the value of k. So how to approach this sum? If you want to know the value of k, I must know what is my point S. Because the moment I get the coordinate of S, I will put those abscissa and ordinate, that is the value of x and y in this equation, because it will satisfy the equation. And from there, eventually we are going to get the value of k. So our main task in this problem is to find out the coordinate of the point S. Is it clear? Now, PR is the diameter. So let me do one thing. Let me join the points. PQ and QR. So definitely this angle is the angle in the semicircle. As PR is the diameter, PQR is the angle in the semicircle. Hence this angle will be nothing but 90 degree. And if it is 90 degree, what I will do, the product of this slope, that is the product of the slope PQ and QR will be equals to -1. What is the slope of PQ? The slope of PQ is it's coming to 8 over 12. It's 2 over 3. And what is the slope of QR? It's our 10 minus 4 divided by 9 minus alpha. So that gives us 6 over 9 minus alpha, right? As they are perpendicular to each other, so I will say the product of their slopes will be equals to -1. So from here we can write 4 over 9 minus alpha is -1 implies 4 is -9 plus alpha. So from here we are getting alpha is 13. So if alpha is 13, the coordinate of the point R is nothing but 13, 4. Is it clear to all? So the first task, which is unknown, that is the value of alpha, we got it. Okay, so now to find out the coordinate of S, we must know the equation of SR. At the same time, we must know the equation of SQ. Because the moment we know these two equations, we can solve these two equations to get the value of S. Now, QS is basically the tangent to this circle, whose P and R are the extremities of the diameter. So what will be the equation of the circle? Equation of the circle is, by using the diametric form, we can write plus, this is equals to 0. So we are getting basically x square minus 10x minus 39 plus y square minus 6y plus 8 equals to 0. That gives us x square plus y square minus 10x minus 6y minus 31 equals to 0. So this is the equation of the circle. So what will be the equation of the tangent? What will be the equation of the tangent QS? As Q is a point which is on the circle, and we are going to find out the equation of the tangent passing to the point Q. Hence, the equation will be x into x1, the Cartesian form we will use. So it is x into x1 plus y into y1 minus 5x plus x1 y plus y1 minus 31 equals to 0. What I have done, I have used the Cartesian form. Why? Because the Cartesian form of the tangent you can find out if you know that the point is on the circle, and here the point Q is on the circle. That is why I have found the equation of the tangent QS by using the Cartesian form. So the equation of QS will be, let me just simplify, 9x and 5x minus, so it is 4x, 10y and minus 3y, so it will be plus 7y minus 45 minus 30 minus 31 equals to 0, implies it's 4x plus 7y. This one will give you 75, my 75 and 31. How much it is coming? 606, right? So minus 106 equals to 0. So this is the equation of the line of the tangent QS. Is it clear to all? Now we are going to find out the equation of, we are finding out the equation of the tangent RS. Again, the point R is on the circle, so we are using the Cartesian form. So what will be the Cartesian form of the tangent RS? X1 plus y1 minus 5x plus x1, that is x plus 13, minus y plus y1, that is 4, minus 31 equals to 0. So let me open the brackets. So we are getting 8x plus y minus 65, 12, 31. So it's basically 8x plus y, and this is coming to 65, 31, that is 96, 96 and 12. So 108, which is equals to 0. Okay. So this is the equation of, your tangent RS. Clear? Now, to find out the coordinate of S, what I will do, I will simply solve these two equations, because these are the two equations of two tangents QS and RS respectively. And if we solve it, we are going to get the value of, the coordinate of S. So let me just quickly let me multiply the equation 1 with 2. So we are getting 8x plus 14y minus 212 equals to 0. So let me just subtract 13y and 212 minus 108 will give us 104. So your y is coming to 104 over 13. So it's coming to 8, right? So y is your 8. So what about your x from this second equation? 8x plus 8 minus 108 equals to 0 implies 8x is 100. So x is coming to 100 over 8. So 25 over 2. Is it clear? Therefore, the coordinate of AC is 25 over 2, 8. Now, this point is on the line 2x minus ky equals to 1. Hence, it must satisfy this. So, we are getting 25 minus 8k is 1. That implies 24 is 8k. That implies k is 3. Is it clear to all? Pretty simple sum. Pretty simple sum. Only know the basic funda. Only know the formula and the tips and tricks, what I am saying every time in my lecture. So remember that and do it easily. That is why I always say that coordinate geometry part is the easiest part among all the chapters in our syllabus. Okay. So our answer is the value of k is 3. Is it clear to all? Okay. Now see, two things we are going to discuss over here. It is that the area of the quadrilateral formed by the pair of tangents drawn from a point x1, y1. Let me just draw it what they have said. There is a circle. So there is a circle and there is a point outside this circle which is your x1, y1. Clear? And what they have given you? The area of the quadrilateral formed by the pair of tangents drawn from the point x1, y1 and the radii of the circle is equals to whatever. That we will prove. So from here, from the point x1, y1, we are drawing two tangents. This is one tangent and this is another tangent. Okay, I have drawn these two tangents. Let me say this tangent, let us denote this point be P and this is, let us say A and this point is B. Okay. Now, if I join the point of contact A with the center of this circle, this will be definitely the radius. This will be definitely the radius and this is perpendicular. Okay. We join this point also. So what is that quadrilateral we are getting? Let the center be, let us say this is R. So we are getting the quadrilateral as PARB. Now we have to find out the area of this quadrilateral. Okay, let us say the equation of the circle be S, which is x square plus y square, 2gx plus 2fy plus c. Okay, so what is the power of the point x1, y1 with respect to this circle? It is x1 square, y1 square, 2gx1, 2fy1 plus c. And the length of the tangent, which is your PA, which is same as your PB, is nothing but root over of S1. That we all know. Now let me do one thing. Let me join P and R. So we have to find out the area of the quadrilateral. We have to find out the area of the quadrilateral PARB, which is same as area of the quadrilateral PARB is same as twice the area of the triangle PAR. Because these two triangles are congruent. This is 90, this is 90, this side is equals to this side, and this is the common side. So these two triangles are congruent, hence their areas are also equal. Therefore, the area of the quadrilateral PARB is same as twice the area of the triangle PAR. Now, PAR is a right angle triangle whose radius RA, this side RA is basically the radius which is R, and the length of the tangent which is PA is root over of S1. Therefore, the area of the triangle PAR is half base into height. So we are getting this thing as half R root S1. So what will be the area of PARB? It is 2 times the area of PAR, which is 2 times half R root S1. So that gives us R root S1. That's it. Is it clear? So R root S1 is basically the area of the quadrilateral formed by the tangents PA and PB and the radius R of the given circle. That's exactly what it is written over here. Okay. Now, the second part that we must remember this. Again, I'm telling you, if possible, remember. If possible, try to remember this formula. If not, then all you have to do is you have to do by the same way as I have done right now. You have to do all this workout. So that will consume your time. So it's better to remember this particular result as a formula. Okay, it's R root over S1. What is R? The radius of the given circle. What is S1? This is the power of the point x1, y1, a point which is outside the circle with respect to the given circle. Okay, so the area of the quadrilateral is R root over S1. Now, what is the second point to be noted? That the angle between the tangents drawn from the external point x1, y1 to the circle is given by this. Okay. So all we will do is we will find out, let us say this angle is theta. If this angle is theta, we will show that your tan theta, that is the angle between these two tangents, is 2r root s1 divided by s1 minus r square. And I will definitely prove this, but it is always better to remember this as a formula. Remember this result as a formula. Now see how I am doing. I have to find out this theta. Okay, your tan theta will be this. How to do this one? You see, your this angle will be nothing but theta by 2 because your PR is going to divide the angle APB in equal half. So the angle APR is nothing but theta by 2. And please tell me, what is your tan theta by 2? From the triangle PAR, look it carefully. From the triangle PAR, your tan theta by 2 is perpendicular by base. So your tan theta by 2 is R over root S1. Is it clear? Now, what is tan theta? Tan theta is basically 2 tan theta by 2 divided by 1 minus tan square theta by 2. So simply replace the value of tan theta by 2. It's R over root S1 divided by 1 minus R square by S1. So if I simplify, we are going to have 2R S root of S1 divided by S1 minus R square. So that gives us 2R root S1 divided by S1 minus R square. And that is your tan theta. That's exactly what we have proved. Okay. So the angle between the two tangents drawn from a point outside the circle is nothing but 2R root S1 divided by S1 minus R square. That is the angle between the tangents drawn from the external point x1, y1. Is it clear? What is R? R is the radius of the circle. What is S1? It is the power of the point x1, y1 with respect to the circle given. Okay, so treat these two results as a formula. Treat these two results as a formula. If it is required, I will use this to short our time in the examination hall. Okay. So now let us take some problems on this. See this question. It's a straightforward question. Find out the angle between two tangents from origin to a circle. So I'm drawing a circle which is whose center is at 7 comma minus 1, whose center is at 7 comma minus 1, and whose radius is 5 units. Radius is what? 5 units. Okay. Now what they have said, what is the angle between the two tangents drawn from the origin? Now your origin is outside the circle. Your origin is outside the circle, and from this origin you are drawing two tangents. Is it clear? This is our origin. How we know that the origin is outside the circle? Simply find out what is the power of the point 0, 0 with respect to this circle. You are going to have 7 square plus 1 square minus 25, which is greater than 0. That is why I told you the origin is outside the circle. Clear? Now you have to find out the angle between them. What we know? We know that tan theta, if theta is the angle between these two tangents, the formula is 2r root s1 divided by s1 minus r square. So what is the radius of this circle? It is 5. And what is the length of the tangent drawn from 0, 0? So we can find out that it is under root 7 square plus 1 square minus 25. Is it clear? How I got this? 7 square plus 1 square minus 25 is the power of the point origin with respect to the circle. So root over of that power of point will give us the length of the tangent. So here we are getting it's equals to 49 plus 150 minus 25 is 25. That is 5. Okay. So what will be your tan theta? The angle between the two tangents is 2 times r root of s1, which is again your 5 divided by s1 5 minus r square. R square is 25. I'm sorry. Here s1 is 25. S1 is the power of the point, which is your 25. Okay. So you can see that your denominator is coming to 0. So it is infinity. So tan theta is infinity. It implies your theta is coming to 90 degree. Okay. So the angle between these two tangents is nothing but 90 degree. Hence option D is correct. Is it clear? That is why I told you it is better to remember the formula. In this kind of problem, we can directly use the formula to get the answer very quickly. Okay. Let me take another problem. See this question. In this question, they have said that the angle between a pair of tangents from a point P to the circle is given. So this is the circle and there is a point P outside the circle. There is a point P outside the circle, and from this point P, we have drawn two tangents. We have drawn two tangents. This one, and let us say this one. Okay. So now this point, let us say this is A and this is B. And they have said that the angle between these two tangents is 2 alpha. The center of the circle, let us say C, is minus 2 comma 3, and its radius r is root over minus 2 whole square plus 3 square minus 13 cos square alpha. Okay. So we are getting actually root over minus 13 cos square alpha. So we are basically having 13 1 minus cos square alpha minus 9 sin square alpha. So this is under root 13 sin square alpha minus 9 sin square alpha. So that gives us 4 sin square alpha. So that is 2 mod sin alpha. Is it clear? So that is the radius of the given circle. Now we have been said to find out the equation of the locus of the point P. Let us say the h comma k be any point on the locus. That is the coordinate of P we are assuming at h comma k. Now we have to find out the locus of this point. How to do it? Let me join P and C. Okay? As well as PA and PB. Clear? Now we can easily see that this angle, since this whole angle is 2 alpha, therefore this angle will be alpha. The radius CA is same as your radius CB, which is your 2 mod sine alpha. Right? And what is your PA? PA is basically the power of the point P with respect to the given circle, which is your PA is actually the length of the tangent. So the length of the tangent is basically the square root of the power of the point P with respect to the given circle. Right? The center C is minus 2 comma 3. We have to find out the locus of point P. That is, we have to find out a relation between H, K and constants. Now, if we consider the triangle PAC, then we will say that your sine alpha is basically CA over CP because this angle is 90 degree. Yes or no? Now, what is your CP? CP is the distance between these 2 points, which is nothing but h plus 2 whole square plus k minus 3 whole square. And what is your CA? CA is nothing but 2 mod sine alpha. Is it clear? So now, in the triangle PAC, sine alpha is CA by CP. So we can write this thing as sine alpha equals to CA, which is the radius, divided by CP. Your CP is root over h plus 2 whole square plus k minus 3 whole square, correct? Now, if I square both sides, we are going to have h plus 2 whole square plus k minus 3 whole square into sine square alpha, which is equals to 4 sine square alpha. So sine square alpha goes off. So we are left with h plus 2 whole square plus k minus 3 whole square is equals to 4. So this is the equation of the locus because this contains your h, k and the constants. So this is the equation of the locus of the point P. Thus the equation of the locus will be x plus 2 whole square plus y minus 3 whole square, which is equals to 4. Is it clear? So this is the equation of the required locus. Understood? Okay, so let us move for the next problem. The question is, a circle touches the line x equals to 0 and y equals to 0. X equals to 0 is the y-axis and y equals to 0 is the x-axis. And this is the equation of a straight line. The circle is touching both the x-axis, y-axis as well as this line. And the center is in the first quadrant. The center is in the first quadrant. Okay. So let me just draw this diagram first. The line, which is your 3x plus 4y equals to 3x plus 4y equals to 120. Okay. So now you see, you have to find out the center of this circle. We have to find out the center of this circle. Okay. Now, as it is touching the both x and y axis, let us say the center is r comma r. If the center is r comma r, then its radius is also r. As it is touching the both x and y axis, it means what? The radius will be nothing but r. Okay. Now, if I draw a perpendicular from the origin on this line, again the same funda I am using. If I draw a perpendicular from the origin on this line, it is going to intersect the circle at the point of contact. Because 3x plus 4y equals to 120 is basically the equation of the tangent to the circle. And if I draw the perpendicular from the origin to this line, to this tangent, it is going to intersect the circle at the point of contact. And this distance will be nothing but the radius of the circle. So what is the perpendicular distance drawn from the center on the given line? Minus 120 divided by root over of 3 square plus 4 square, and which is equals to the radius of the circle. So from here we are getting 7r minus 120 divided by 5 is equal, modulus of this is equals to r. Okay. So from here we are getting 7r minus 120, which is equals to, if you square both sides, you are going to have 25 r square, right? So which can also be, don't expand it, do some smart work. So it's 5r square is 0. So if I use the formula a square minus b square, we are going to have a plus b, a minus b, which is equals to 0. So from here we are getting 12r minus 120 into 2r minus 120 is 0. So either your r is, or your r is 120 over 2, that gives us 60. Is it clear? Therefore, the center of this circle will be at either 10, 10, or it can be at 60, 60, because two values of r we are getting. And we can easily see from the diagram also that fulfilling this condition, that it is touching the x and y axis as well as this line, we are going to have two such circles. One is the circle which is shown here, and another circle will be somewhere here, which is touching the y axis as well as, my diagram is not perfect, but you can understand. It is going to touch this line as well as it is going to touch this line, and that circle will be formed. So that circle will have its center at 60, 60, and this circle is having its center at 10, 10. So two such circles in the first quadrant are possible. Is it clear? Hence option A and B are correct. Okay. So let me just check. Yeah. Is this question clear to all of you? Absolutely. Okay. Now, see this question. The question is, let the tangents at 2 points A and B on the circle this. So there is a circle. There is a circle. Let me draw it first. A circle is there, whose equation is x square plus y square minus 4x plus 3 equals to 0. Okay. So before doing anything else, first of all, I will find out what is its center and what is its radius. The center we can easily find out. It is basically 2, 0, and the radius will be root over 2 square plus 0 square minus 3. So that gives us 1. So radius is 1, center is at 2, 0. Now, There are two tangents drawn at the points A and B to this circle, which meet at the origin. Now, my question is this origin on the circle or outside the circle or in the circle? So we have to find out the power of this point. So we can easily see that the power of this point, the origin, is coming to what? Which is 3 greater than 0. It means that the origin is outside the circle. Okay, so origin is somewhere outside the circle, and let me draw two tangents which are intersecting at the origin. Is it clear? So this is my origin 0, 0, right? Now we have to find out the area of the triangle OAB. We have to find out the area of the triangle OAB. What is A and B? A and B are the two point of contacts on the circle. So now we have to find out the area of OAB. How to do that? Okay, so for that, let me do one thing. This is my center. So from the center, again, the same rule I am doing. I'm joining the center with the point of contact. So they will be the radius. And let me join the center of the circle. Let me denote the center of the circle with C and the origin. Okay. So now you have to find out the area of OAB. Now, one thing for sure, that your triangle OA, let me give a name of this point. Let us say this is P. Now, let us say the angle between the tangents be 2 alpha. Okay. So, this angle will be alpha because we all know that the line joining the point which is outside the circle and the center of the circle is going to divide the angle between the tangents into 2 halves. So this angle will be your alpha, right? What is your OA? What is your OA? OA is basically the length of the tangent, which is nothing but root over of S1. So that is root of 3. So OA, which is same as your OB, OA is root 3. So this length is root 3. And the radius of the circle we have calculated, that is 1. Therefore, if we consider the triangle OAC, you are getting your tan alpha is nothing but 1 over root 3, perpendicular by base. So from here we can write that your alpha is nothing but 30 degree, right? If alpha is 30 degree, then 2 alpha will become 60 degree. That is, the angle between these two tangents is 30 degree. Is it clear? Now, if you consider the triangle OAB, we can easily see that this angle, the angle between them, between the tangents, is 60 degree, and OA and OB, they are of equal length, which is of root 3. Therefore, area of the triangle will be half into the product of the two sides, which is your root 3 into root 3, that is OA into OB, into sine of the angle between them. From the properties of triangle, we know that for any triangle, if you know two sides, suppose if I know AB and BC, then the area of the triangle, and if you know that the angle between these two sides is theta, then the area of the triangle is always half into the product of two sides into sine of the angle between them. So that's exactly what I have done for the triangle OAB. OA and OB we know, and we know the angle between OA and OB, which is pi by 3. So we have applied this formula for finding out the area of the triangle OAB. So it is coming to 3 over 2 sine 60 degree, it's root 3 by 2. So answer is 3 root 3 over 4. Is it clear to all? So the area of the triangle OAB is 3 root 3 over 4. Hence option B is correct. Is it clear now? Option B is correct. Okay, let us move for the next problem. See this question. The question says that from a point P on the line 2x plus y plus 4 means there is a line. There is a line, and on this line there is a point P. Okay, the equation of this line is 2x plus y plus 4 equals to 0. Which is nearest to the circle? Okay. Oh, one circle is given to us. One circle is given to us, and they have said P is such a point which is nearest to this circle. Now, where does this P lies? Can you tell me? If this P is nearest to the circle, then where should this point P lies? Point P is such a point that if you join that point with the center of the circle, if you join the center of the circle with that point, this line will be perpendicular to the given line. If it is so, then you will say that this point P is nearest to the circle, right? So your CP is perpendicular on the line given, right? And the equation of the given circle is, so what is its center? Because the moment I get the equation of the circle without thinking anything else, I find out two things. One is what is the center and what is the radius. So you people will also do that. So what is the center? Center is 0,6, and what is its radius? I don't know whether it will be required or not, but yeah, I always find out that thing first. Minus C. So it's coming to 1. So radius is 1 and the center of this circle is 0,6. Now let us read the question. Now, which is nearest to the circle? Okay. Tangents are drawn to the given circle. So from the point P, you are drawing the tangents. This is one tangent and this is another tangent. Is it clear? These are the two tangents I have drawn. Let us say these 2 points are A and B, which is also given to us. Okay. Now you have to find out the area of the triangle PACB. Okay. So we have to find out the area of the quadrilateral PACB. That's it. Is it clear to all? Is this question clear to all of us? Okay. Now the question comes, how to do it? What is this point P? Let us say this point P is lying on this line. Point P is lying on this line. So from this line we can say y is minus 2x plus, minus 4. So if your x is alpha, then your y will be minus 2 alpha minus 4. This is any point on this line. Let us assume this is my point P. Yes or no? This is my point P. Now what is the slope of PC? 6 minus 2 alpha y2 minus y1 divided by x2 minus x1. So it is coming like 2 alpha plus 10 over minus alpha. Is it clear? So this is the slope of PC. Now what is the slope of the given line? The slope of the given line is minus 2. And as we all know that they are perpendicular to each other, so we will say that 2 alpha plus 10 over minus alpha into minus 2 is basically minus 1. Okay, since PC and this line, they are perpendicular to each other, so product of their slopes will be equals to minus 1. So what we are getting? 4 alpha plus 20 is minus alpha. So that gives us 5 alpha is minus 20. Alpha is minus 4. So what is the point? The point is nothing but minus 4, 8 minus 4, which is nothing but our minus 4 comma 4. So what is the required point P? P is nothing but your minus 4 comma 4. Is it clear? So one task is over. We found what is that point P lying on the given line which is nearest to the circle. That we found. But we have to find out the area of the quadrilateral. And we all know that the area of the quadrilateral, just now we have learned the formula is R root S1. Can you remember? What is the area of the quadrilateral formed? It is R into root S1. What is R? R is the radius of the circle. What is root of S1? This is the length of the tangent, where S1 is the power of the point with respect to the circle. So in this case, in our problem, please see, we have to find out the area of the quadrilateral PACB, which is nothing but your R into root S1. So what is R? R I got, which is equals to 1. So the area will be 1 into root S1, which is nothing but root of S1. That is, we have to find out the length of the tangent PA or PB. It's all same. So what is the length of the tangent PA? The point outside the circle is minus 4 comma 4. So find out the power of the point S1, which is nothing but S1 equals to 16 plus 16 minus 48 plus 35. So we are actually having 16 plus 16 is 32 minus 48 plus 35. So we are having actually minus 16 plus 35. That gives us 19. Okay. So this is the power of the point P with respect to the given circle. Therefore, what is the length of the tangent? It's root 19, and which is nothing but the area of the quadrilateral PACB. Am I correct? Hence, option C is correct. Have you understood? If you remember the formula, how easily you can solve a problem. Directly use that property, because several times in JEE Mains, the questions based on the area of this quadrilateral came. That is why I told you to remember this as a formula. R root over of S1. Two things you have to remember: the area of this quadrilateral formed and the angle between these two tangents, which we have already learned. What is that? 2R root S1 divided by S1 minus R square. That is your tan theta, and theta is the angle between these two tangents. So these two results, please do remember. Area of the quadrilateral is R into root S1, and the angle between the tangents is this one. Okay. So our answer is option C, yes. Clear? Now, let us come to the last part of this lecture, which is called your director circle. What is your director circle? We have already done a lot of sums on tangents. I hope you people are clear with this conception of tangents, not only the definition, but also how I'm approaching to solve a problem given in tangents, right? Now we are coming for the director circle. What is the director circle? Now don't read this, I'm telling you. The thing is that suppose there is a circle, and from a point outside this circle, you have drawn two tangents. Suppose this is one tangent, and let us say this is one tangent. Okay. So from this point outside the circle, you have drawn two tangents. Now the question is, if the angle between these two tangents is 90 degrees, that is, they are perpendicular to each other, then what will be the locus? What will be the locus of this point? the locus of the point P is what called your director circle. Is it clear? So in a circle you have drawn two tangents and the angle between the tangent is 90 degree. If it is so, then what is the locus of the point P? The locus of point P will be nothing but a director circle. It is called director circle. What will be the equation of the locus? That I will be coming. But first you understand the definition. When the locus of the point through which if you draw two tangents, the angle between the two tangents is 90 degree. Then the locus of point P is what called your director circle. And this director circle you will find out the same definition is applied for parabola, for ellipse, for hyperbola, for everyone. So remember the definition. Clear? So now I will find out what is the locus of point P. The angle between them is 90 degree. Let us say the equation of this circle be x square plus y square equals to a square. I am taking the standard one. You can take the general form also. Doesn't matter. So now this is the equation of the circle. And we know that from a point P, let us say the point be h comma k. H comma k is any point on the locus. From any point P outside the circle, if you draw the tangents, the angle between these two tangents will be, just now we have learned, tan theta. If this angle is theta, then this angle is theta. Then tan theta is, we have learned the formula, 2r root s1 over s1 minus r square. Now they have said that this, according to the definition, this angle theta is 90 degree. If it is 90 degree, so tan 90 is coming to undefined. So which is true only when the denominator is equals to 0. Then only this result will give us undefined. So s1 minus r square is 0. What is s1? S1 is the power of the point P with respect to the circle, which in this case is nothing but h square plus k square minus a square. And what is r? R is the radius of this circle, which is nothing but your a over here. So it is a square equals to 0. So the equation of the locus is h square plus k square equals to 2a square. Thus, the equation of the locus is what? X square plus y square equals to 2a square. And that's the equation of the director circle. Is it clear? This is the equation of the director circle. Right? Now, can you observe one thing? The given equation was x square plus y square equals to a square, and the director circle we got it as x square plus y square equals to 2a square. Yes or no? So now we can easily see that the given circle and the director circle, they are concentric. That is why I have written director circle is always concentric with the given circle. And the radius of the circle, of the given circle, is a. But the radius of the director circle, look at carefully. The radius of the director circle is what? It's root 2 times the radius of the given circle. That's exactly what I have written. Its radius is, it means the radius of the director circle is root 2 times the radius of the given circle. Is it clear or not? So if I tell you that, suppose we have taken, let us say, x square plus y square is say 100. So if I ask you to find out the equation of the director circle, so what I will do, it is the concentric circle with this circle, right? Concentric circle. But the radius will be root 2 times the radius of this circle. The radius of this circle is 10. Is it clear? Therefore, the equation of the director circle will be what? it will be x square plus y square equals to root 2 times the radius of the given circle. So it will be x square plus y square is 200. That's it. This is the equation of the director circle. So what we have learned? What is the director circle? The locus of the point of intersection of perpendicular tangents to a circle is called a director circle. And the equation of the director circle is, it is always concentric with the given circle and its radius will be root 2 times the radius of the given circle. That much you have to remember. Okay, let me take a problem. See this question, what they have said. They have said find the locus of the point of intersection of two perpendicular tangents. The locus of the point of intersection of two perpendicular tangents to the circle x square plus y square equals to 25. Now how the tangents will be? These two tangents will be perpendicular to each other. Means the locus of the point of intersection is guaranteed is going to give us the director circle. And the director circle will be concentric with this circle. So its locus will be x square plus y square equals to root 2 times the radius of the given circle. The radius of the given circle is 5. So it will be root 2 times 5 whole square. This is what? This is the locus of the given point. Or we can say this is nothing but the equation of the director circle. Why it will be a director circle? Because the tangents are at right angles. That is why it will be a director circle. So its equation will be x square plus y square equals to 50. That's it. One line sum. If you know that two perpendicular tangents, the locus of the point where the two perpendicular tangents are meeting is nothing but the director circle, and the equation of the director circle is same as the equation of the given circle because it is concentric with that circle, and its radius will be root 2 times the radius of the given circle. That's it. Okay, so the locus of the required locus is nothing but the director circle whose center is whose equation is x square plus y square equals to 50. Let me take another example. The question is, the tangents are drawn from any point on x square plus y square equals to 20. Okay, let me draw a circle first. So there is a circle whose center is at the origin and radius is root 20. Okay, its radius is root 20. Now there is another circle x square plus y square equals to 10. So again, it will be a concentric circle. So it is going to come somewhere here, right? Okay. So this equation is x square plus y square equals to 20, and this equation is x square plus y square equals to 10. Now we can see that the radius of this circle is root 10. Okay. Now what they have said, now tangents, you take any point on this circle, on the outer circle, and draw tangents to the inner circle. Draw tangents to the inner circle. So I have drawn tangents to the inner circle, right? And the question is, what is the angle between these two tangents? That's the question. Now here I don't need to do anything. Only by inspection you can say what will be this angle. The radius of the outer circle is basically root 20 whole square, which can also be written as root 2 into root 10 whole square. And the radius is nothing but root 2 times the radius of the given circle. Getting my point? So this circle is nothing but, this is basically the equation of the director circle. And this is the given circle. Okay. Now, as this is a director circle, so I'm sure that the angle between these two tangents will be nothing but 90 degree. See, I have done nothing. Only by inspection, you can say what will be the angle between these two tangents. Is it clear? If it is root 2 times the radius of the previous circle, I mean the given circle, then this locus is the director circle. That is, the angle between the tangents is 90 degree. That's it. That's exactly what we have done here. Therefore, the angle between the required angle between the tangents is 90 degree. Is it clear to all? So I hope you have all understood this class. If not, please do replay this video and see this one, so you will be comfortable with the theory part that we have gone through, mainly the conception of tangents that we have covered here. So see you in my next class. Till then, stay tuned to us, and if you have not subscribed my channel, please do subscribe and share it and like it. Thank you so much.